This is the N1050-PR, and it's wired to a contactor to operate 3 heating elements. The wiring is very straightforward. We've got a PT100 sensor, which is going to measure our temperature, and on the control phase we've got 230 volts coming in. We've marked them 8 and 9 because that's how the terminals marked on the controller. So we've got our 230 volts coming in, and then we have this little link wire here which comes across into terminal 6, and that's just going to sit on one side of the relay. When we call for heat, the relay is going to close and it's going to send our 230 volts on number 7 to the contactor coil. Now, although this is a PID controller, we're actually going to use it in a thermostatic mode. The main reason we're using this controller is it's got the time function that the customer requires. So looking for a good timer. Yes, a thermostat would work, but obviously you wouldn't have the timer function, so you wouldn't be able to set it to heat for an hour and then shut off. And also it wouldn't fit the existing aperture in the control panel. Whereas this is a 1/16 DIN, so it just slides straight in. So yeah, once we've got our sensor connected, you'll see that we will read roughly room temperature, and here's our current set point. And at the moment we've got no other lights or indications on the controller, so the controller's off, contactor's not energized, and in a very simple heating mode, we're going to press the P button until we get to run, and we're going to say run yes, and as you can see we've gone into run. Controller's telling us it's on and it's running its cycle, and the output lights come on, and you probably heard the contactor close. So as soon as we want that off, we can just go run no, and that's a very straightforward manual way of heating. But we've also programmed in a timer. So if we go to P button again, single tap on the P button just brings up the very basic menu. So single tap on the P, and we're going to go to program number 1, which is correct. And if we go to yes this time, back through with the P button, we can actually see the countdown of the program. So we're running segment 1 of the program. It's a very straightforward program with 1 segment. We've just set it for a minute, so it's counting down now, and when that minute times out, the output will just turn off. Now we can adjust obviously the times to suit, but this is just a very straightforward, simple setup. And just while that's counting down, I'm going to show some of the more advanced menus, which is currently cycling through. So this is the normal operator screen, obviously the measured temperature here and the set point there. Now it's continuing to count down, and it will reach the end of its cycle, despite the fact that, as you can see, we're 80 degrees different between our set point and our measured value. We have a tolerance which will need adjusting to suit this particular process. So if we go press on the P button and hold this time, you see PRTB, program time base. So we're in the program menu now. We're looking at program number 1, and we have this P.tol set to 0. So with 0 tolerance, the program will just skip along and finish regardless of what the temperature is.